Hello everyone. In this video we'll talk about even and odd functions and what is the difference between even and odd function. First of all, let's start with the definition of an even function. So an even function is the function, when you look at the graph of the function, it will be symmetrical about y equal x. Let's look at the function, the parabola here. You will notice that the line, the y-axis, is a line of symmetry. Any point here is symmetrical on the other side. Okay. In general, when f(x) equal x squared, this is an even function. If you look at the graph of the x squared, it is symmetrical about the line y equal x, y-axis, which is x equals 0. Algebraically, the f of the negative number x is equal to fx. For example, if this point here is 1, okay, and this point here is -1. If 1 is here, let's say this is -4 or -3, and that's going to be the same for f -1. So f -1 basically equal to f1. In here, I know that this is x squared. If I'm talking about number 2 and number -2, by substituting f2, it will be 2 squared, which is 4. f -2 is basically -2 squared, which is also 4. In this case, we can tell that, yes, it is an even function, okay? Moving on to the odd functions. Now, odd functions, well, the graph will be symmetrical about the origin. If you do kind of rotation, you will notice that this part here is kind of reflected here. That's called symmetrical, the graph is symmetrical about the origin. Algebraically, f (x) will be -fx. Let me give you an example of the function x cubed. Okay, the function x cubed, the graph is going to be something like this. Okay, if I take a point like let's say 2 and -2, I will notice that f2 by substituting here will be equal to 2 cubed, which is 8. f (2) will be equal to -2 cubed, which is -8. So they are now the same. But if you put a negative outside here, they will be the same. So f (x) will be -fx. That's an odd function. Now, the third thing, if it is not symmetrical about the origin or symmetrical about the y-axis, like this case here, symmetrical about the y-axis or symmetrical about the origin. If it is not symmetrical about the y-axis or symmetrical about the origin, then it's neither. So neither even nor odd, it's not symmetrical with respect to y-axis or to the origin. Let's find out graphically whether this function is even, odd, or neither. By looking at this function, we will notice that the y equal x is a line of symmetry. So in this case, it's an even function because it's symmetrical about y-axis. So y-axis acts as a line of symmetry. In this case here, you will notice that if you look at the y-axis, if it is symmetrical, this part should come here. However, this part is like has been rotated until it comes here. So the origin is basically the point of symmetry. So it's an odd function and it's symmetrical about or with respect to the origin. And the origin is the 0.00, which is this one here. Now, by looking at this function here, you will realize that it is not symmetrical about y-axis and not symmetrical about the origin. So it's neither. Okay? Now, we'll try to find algebraically whether a function is odd, even, or neither, whether it's symmetrical about with respect to y-axis, origin. So let's try this one. In order to tell whether it is odd, even, or neither algebraically, first of all, you need to remember that even means fx equal f negative x, odd f negative x equal negative fx. I'm going to take it better to remember it this way. F negative x equal fx. Okay? Now let's try to find f negative x. F negative x will be equal to, I'm going to put everything down, but instead of x, I'm going to replace it with negative x. And then I'm going to continue everything, minus 5, which is equal to negative 3. Negative x squared, anything squared will be positive, like negative 2 squared is negative 2 times negative 2, which is 4. Negative 3 squared is negative 3 times negative 3, which is 9. Negative x squared is basically negative x multiply negative x, which is x squared. So this is going to be x squared minus 5. What did we notice here? We noticed that fx is basically the same as f negative x. So compare between the, let me just write f negative x. I want you to compare between the first function and this one, just to see if this rule is applied. We notice that f negative x equal fx, they are the same. Therefore, fx is an even function. And if it is an even function, then it's symmetrical with respect y-axis. Okay? Because when it's even, it is symmetrical with respect to the y-axis. Now, let's try this function here. Again, I'm going to take h negative x. I'm going to substitute x by negative x. So I'm going to put negative x here and negative x here. So instead of x, I'm just putting negative x. And then I will try to simplify. You need to simplify it. So it's going to be equal to negative x will be the same. Negative x squared is x squared. Now I try to compare between this one and this one, between these two. Are they equal? No. There is a negative here, there is no negative here. So they are not the same. So you will say it's not even. H negative x is not equal to hx. So therefore, hx is not even function. Okay? Now, you will try to find negative hx. So negative hx, which is equal to, you are going to take the function, multiply it by negative. So it's like you're doing this, negative, and put the function. X over x squared minus 1. Now, when you multiply by negative, the negative goes only to the numerator. You need to remember this. That's going to be equal to negative x over x squared minus 1. Now you need to compare between h negative x and negative hx, between these two. Are they equal? Yes. So I will say h negative x equal negative hx. Therefore, hx is an odd function. And if it is an odd function, then it will be symmetrical with respect to the origin. Okay, that's when it is odd function. Now let's move to the last question here, and we are going to do the same. G negative x equal 2, and then I have cube minus 3, and then I have squared. Instead of x, I'm going to replace it by negative x. So first you need to test whether it's even. So g negative x will be equal negative x cube. Anything cube will be negative. So let's remember negative 2 cube will be equal negative 2 multiply negative 2 multiply negative 2. That's negative 8. So the negative will stay. Same with x. Negative x cube is going to be negative outside. So it will be negative x cube. So it's negative x multiply negative x multiply negative x. And that's basically negative x cube without the bracket. So I can say 2 and then negative x cube. And then the negative can go out, which is going to be negative 2x cube in a simplest form. Okay, and here negative x squared, we said it's going to be x squared. Now, if you compare between these two, they are not equal. So we'll say g negative x does not equal gx. So it's not even. Now we will try if it is odd. So it will take negative gx now, and that means you will multiply the whole function by negative, which is the original function, 2x cubed minus 3x squared. When you multiply by negative, you will put the negative inside, okay? That's going to be equal negative 2x cubed plus 3x squared. Now you should compare between these two, g negative x and negative gx, and again, they are not the same. So g negative x does not equal negative gx. So the function is neither odd nor even. So that's everything, guys, for this lesson. Please let me know if you have any questions, and see you in the next video. Bye bye.